problem is calculate the area between fx is equal to 1 over x squared minus 4, the x-axis on the vertical lines, x is equal to minus 1 and x is equal to 1. So we have to find specifically this area between the graph and the x-axis. First we have to integrate by integration with partial fractions. We have to factorize the denominator of the original function, and later we get a pair of functions. It will be a over x plus 2 plus b over x minus 2. We have to find a and b, so we find a, which is minus a quarter, and b, which is b is equal to a quarter. We have to substitute these values in this function, and later we get the integral with the substituted values. We have to leave out minus and the 1 quarter, and we get the integral with the minus 1 quarter leave it out of the integral. So we have to integrate this function that, with the 1 quarter out. Here we integrate it and we factorize it the 1 quarter. Here we have a subtraction of logarithmics, so we apply the law of logarithmics and we get a division. So this is the final integral.
And then we calculate the area with the fundamental theorem of calculus. So we substitute the x1 and x equal minus 1 with pb and pa minus pa with an integral, and after substitute the integral we get the value of the both values of the substitute integrals.
Once we have the values for pb and pa, we need to solve with the formula that we already have. We substitute the value that we got in the previous step and we solve for each one. We get our result in the absolute, that is the absolute value of minus 0.5492. That this only tells us that the area is under the x-axis, but it's supposed to be positive, so our area is 0.5492 units squared.
After finishing this problem, we can conclude that there is a huge variety of methods of integration for solve multiple problems in real life. For example, this topic could be used for like a tool for an engineer to calculate areas of buildings, bridges, etc. for his work.